Alright, this recording is on how to solve complex equations, meaning that you have various steps to do before you find out what x is. Most of the times this means that there are x's on both sides of your equation. There are multiple constants and sometimes parentheses. So you see here, this is kind of an example of what a complex equation is. But let me go back to like a one-step equation, just kind of so we can review before we apply everything that you know from those. Alright, so here you know what you do is you do the opposite to the variable that they're doing, so you can kind of undo the problem and get x by itself. So you always look for the x side, and then we undo what is on that side. So they're multiplying, so we will divide. When you do this, 8 divided by 8 equals 1, so we're left with 1x on one side, and then the answer on the other. Same thing goes for addition. They are subtracting a -3, so I'm going to add a -3 to both sides. That cancels each other out, and then we're left with 3 on the other side. Alright, so we can step up our equation, and we can make them 2 steps. So an example is where we have more than just one step to get what our x equals. So always look for your x side, start undoing from the outside in. So you're kind of doing the order of operations backwards. If you look at order of operations, the least important thing is adding and subtracting, so that's where I'm heading first. So they're subtracting 5, I'm going to add 5. And then we can divide by 2. So 35 over 2, you can go ahead and divide it out if you want to, but it's not necessary as long as it's in reduced form. Alright, so let's apply those two concepts to our beginning guy that we had written. So this is just a really long equation. Alright, so I always suggest simplifying your equation before you start subtracting and adding and multiplying and dividing on each side. So we're going to like make this side as simple as possible and then make this side as simple as possible before we proceed. Alright, so if I look at this side, I can combine these two things. So I'm going to go ahead and do that. Now remember, if they're on the same side of the equation, you do whatever it says. If it says subtract, you subtract. The only time we do the opposite, like the previous problem, is if they are needing to go get off of that side or taking it to the other side. So as long as you don't cross the equal sign, you do whatever it says. Didn't touch this guy. Right, and on this side, I have 2 constants that can be put together. So 13 take away 3 is 10, and then I didn't really touch that. Alright, so now this equation is as simple as it can be on each side. We have 2 expressions that are simplified. Now our goal is to have x equals and an answer. So notice we have x's on both sides. So we don't want x equals 6x, as an answer, because we just want to know what x is. So we want our x's on one side or the other. So it's up to you, which side that you want your x's to both be on. I have a habit. I was taught how to do that way back when, to always have my x's on the left side. So that's pretty much what I always do. But you can also put your x's on the other side. A lot of people like to choose the side that makes their x positive, so that's the side they choose. Now, if you do it the opposite way as I do, and you put your x's on the right, our in-betweens, like all the work that we're going to have in between, will look different, but our end result will be the same. Alright, so I have x's on both sides. I only want x's on one side. I'm going to pick my left side. So I want to get rid of this guy. And remember, to get rid of them, we just do the opposite. What I do to one side of the equation, got to do the other. You do the same exact thing to the equation to keep it equal. Right, this is gone. And then this equals negative 3x. And the better you get at this, you can do more than one step at a time. But just for the sake of teaching, I'm just going to do one step at a time. Alright, so our goal is still to try to have x equals. So right now we have a positive 40, so we're going to subtract 40 at both sides. This cancels out. Then I get negative 30, and then just like our one-step equation as before, divided by negative 3. Now, the whole great thing of equations is when you solve it, you can plug it back in to know if you're right or wrong. So let's say you're taking the test online, and you have a few minutes to check yourself. Plug it back in, make sure you have the right answer. So let's go ahead and do that. So really you have two sides. Our whole goal, I'm going to run out of room, is for our two sides when we get to the bottom to have the same number. So this is my check. Alright, so 20 minus 80 plus 40 is 13 minus 30 minus 3. 20 minus 80 is negative 60. So this side equals negative 20. So if 10 is the correct answer that we found at the beginning, then this other side needs to equal negative 20 also. So 13 take away 30 is 17. And then negative 17 take away 3 is negative 20. So this is true. So our final answer is 10. Now don't get this confused as your answer. Don't put in negative 20 as your answer. This is just our check to make sure that our sides did equal. Our answer is 10. Let me do another one. And this is coming out of your book if you're following along. I'm on page 133. If you don't have the paper book, you can always go to MyMathLab and there's an e-book there. Alright, so same thing, simplify each side before we start crossing the equation. So we can put these two together. I didn't touch this one. I can put those two together. Didn't touch that. X is on both sides. Pick a side to get rid of it on. Take 25 away from both sides. Can't do math upside down. Negative 2. So our final answer is 6. And like I said, if you have time, always check them. Taking a test, real quick and easy to go ahead and check it and make sure that your answer is correct. Alright, let's add some parentheses in. So first we always simplify each side. That's what I'm always going to do. Then I'm going to put x's on one side, constants on the other, and constants are just the numbers without variables. And then 3 I'm just going to solve. Alright, so simplify each side. This side can't be simplified any more than 5x. But the other side, when we have parentheses, we always know we can simplify it even more by distributing. So 8 times x 8 times positive 3. This is as simple as it can get. You can't combine x terms with constant terms. Alright, so we did number 1. Number 2, we want our x's on one side, constants on the other. So, sorry, didn't see that that was a 5. So minus 8x. I was thinking that was a 5 and not a 5x. So I'm trying to get my x's on one side, my numbers on the other. Gone. And then solve for my variable. So these steps always come into play. Always simplify before you start minusing and pluses and putting your x's on one side and constant on the other. If you don't, for example in this one, let's say we didn't simplify it, you're making your problem 100 times more complicated by doing, taking this 2x over, and then you've got a bunch of terms. It can be done, it just makes it way more complicated. So that one wasn't too bad. So let's turn the heat up a little bit. I'd say this is probably as bad as you'll see in this class. They can get bad, but they're just longer, not harder. Just more steps to do. Alright, so remember, simplify each side first. So let's look at this side. How can we simplify it? Well, we can get rid of the parentheses by distributing. 2 times x is 2x. 2 times negative 3 is negative 6. This side I can make more simple by distributing. Negative 3x, negative 6. Alright, and we can still simplify this side, so don't forget that part. And we can put these together. There, it's pretty. We know that we've simplified it when we get down to one constant and one variable on each side, or a constant or a variable. So we know we're good. Alright, so pick a side, put your x's on, do the opposite. Get our constants on the other. Divide by 5 since they are multiplying, and our answer is 6. And then again, just quickly showing you our check. Our whole goal is for each side of the equation to come up with the same answer when we get to the bottom. I'm going to try to write this a little bit smaller so we can actually get it all fit in my tiny little space. My new chalkboard. Gone are the days of a nice big gigantic dry erase board, at least for now. And then you also get to see the remnants of all my projects that I do when I'm not working, which is painting. I've been painting some furniture. Alright, so let's simplify this. So we have 2, and this is 3 in here. 6 minus 17, and that gives us negative 11. So our whole goal is to get negative 11 for the other side. So 13 minus 3 times 8, 13 minus 24, and we get negative 11, so our check works. So that's why equations are so beautiful, because we can always check ourselves. Alrighty. The last thing I want to do is include some fractions. So let's use this as our example. So we have fractions. Now you can solve these with the fractions in there, and get the same answer, but it is so much more complex when you leave fractions in your equation. We can get rid of them. Easiest thing to do is you're going to multiply by whatever your LCD would be if you were to make these fractions. So we have 2, 5, and 5. Our LCD would be 10. So that's what I'm going to multiply everything by. So you're making every term 10 times bigger. So let me kind of write this out how it looks so you know what I'm talking about. So we're making each term 10 times bigger. Now remember, this is like doing this. And our whole goal is to get rid of our denominators. When you do this, we can cross cancel. 2 goes into 10 5 times. Notice our denominator is now gone. 5 goes in there once, 5 goes in there twice. 5 goes in there once, 5 goes in there twice. And then I'm going to write what's left. So 5 times 3x, 2 times x, 2 times 39. My calculator is buried. Alright, and now make sure it's simplified on each side. So we count that as a simplifying process. Now we can minus 2x from each side because our goal is to have x equals. So here's 13x equals negative 78. Divide by 13. And x equals negative 6. So these are really nice to be able to plug back in just to make sure you're right, because it is got some complex parts in it that were easy to make mistakes on. So if you do check yourself and your sides don't equal, somewhere there's a mistake. So my number one suggestion is if they don't equal, to redo it without even looking at your work, and then go through your previous work. So then you go through it. If you get the same answer, then something major, you keep doing the same major thing wrong. But most likely if you do it again without looking at what you've done before, you'll find your answer's different and then it'll work out. And let's do another one. Alright, so get rid of our denominators, find something all your bottoms can go into. So 4, 3, and 6 would be 12. So I'm going to make my first term 12 times bigger, my second term 12 times bigger, my third term 12 times bigger. And if you're not good at cross canceling, just multiply across. Like so. And then you can simplify each term. 4 into 12, 3 into 8, 24, 6 into 60. So if you're not good at cross canceling, not a big deal. Minus 8x, minus 8x. Cross canceling is like one of the greatest shortcuts in math that you use in many math classes. So if you're going a lot higher in math, you'll use cross canceling a lot. So if you're not good at it, it's probably something you want to practice at and make yourself good at. So I get negative 2. Alright, and then the last thing I'll go over is decimals. So let's use this as an example. Alright, so again, if you want, you can leave the decimals in it and just go from there, but decimals tend to make things a little bit harder because our numbers have all different place values, and so it makes it a lot tougher. So what the book suggests is to get rid of our decimals. And that is by multiplying by the appropriate number of our word I'm trying to come up with. It's the powers of 10. So 10 powers of 10 would be like 10, 100, 1,000. So what you do is you look at your greatest decimal place value. So here we have the tenths, here we have the hundreds, here we have the tenths. So you'd look at your greatest, and that's how many zeros you're going to add after your 1. So we have a power of 10, which is 10 squared. So when you do that, that moves your decimal spot over 2 times for all your decimals. So if I move it over twice here, I've got 30. It doesn't involve parentheses that are against our number, so multiplied by. Move it over twice, move it over twice. So now our decimal's gone. So if this was 3.7, then I would have had tenth, tenth, and tenth. I would have only multiplied by 10. So let's simplify each side. Can't simplify this side anymore. Now I have a variable and a constant, so now we're going to subtract our x's from one side. Add 180 to both sides. Upside down, minus 70. Nope, positive 70. And our final answer is negative 10. Now, this would be a really good time to plug it back in just to make sure it works, because we did a lot of stuff. Now, if you don't remember to multiply it and make these non-decimals, you're still going to get negative 10 when you get to the bottom. And if you're using a calculator, you know, it is easier to do. It's so much better. Like, I did all that without a calculator. But if I had left them as decimals, I probably would have had to get the calculator out, because I would have had to done some little figuring on the side. So all this stuff I could have done without using too much mental math. Alright, so the last thing we want to do is equations that have either no solution or they have many solutions. So let's look at what one would look like, and then being able to distinguish when you're not going to have an answer or you're going to have many answers. Alright, so let's do our normal thing. So simplify each side. This side can't be simplified anymore, but we can distribute this side by minus 2x from this side. Alright, our x's are now gone, and I'm left with this. This is not a true statement. 6 does not equal 8. Never can, never will. When it is not true, then this does not have an answer. So sometimes you'll see no solution, or you might see that symbol, which means no solution. So if your x's cancel out and what's left is not true, there's no solution. Let's look at a different situation. So let's simplify each side first. Now, just kind of pay attention right here. If you notice, we have the same thing on both sides. But let's say you didn't notice that. X's are now gone. Now we're left with 5 equals 5. Now 5 equals 5 is a true statement. So that means no matter what I put in for my x value, it's always going to be true. If I put in 3, then this side would be 6 plus 5, this side would be 6 plus 5. So it doesn't matter. So if you get here and you notice that the same exact thing is on each side of the equation, then you know this is infinite. solutions, which just means it could be any number in the world and you can never ever not find a number that won't fit. Some people also say all real numbers. So those two things you'll see. Infinity, negative infinity, infinity. Alright, so that's your two situations that you might see where you don't have an answer. Now don't make the mistake of putting x as 0 and then putting x equals 0. If your x's cancel out, there are no more x's, so you can't have x equals anything. So the only time x can equal 0 is if you still have your x and everything on the other side cancels out. But in this case, our x's did cancel out. Alright, if you have any questions, let me know.